Hey there everybody, Mr. D here, and in this video we're going to discuss mutually exclusive events. So let's see, what does that even mean? Mutually exclusive events are when two things cannot occur at the same time. They are each completely separate from one another. If we have events that are mutually exclusive, to find the probability that one or the other occurs, we are going to be adding them. So anytime we see that word or, that's going to correlate to adding different probabilities. So anytime we see or, we're going to be adding. First, let's figure out kind of examples of what mutually exclusive or not mutually exclusive might look like. So question one here, we want to figure out first, are these mutually exclusive or not? A student is enrolled in math 7th period. That same student is enrolled in science during 7th period. Well, those would have to be mutually exclusive events. A student can't be enrolled in the same class during the same period. You can't overlap with math and science at the same time. Unless, I guess we could argue physics is both math and science. So we'll put an asterisk by that one. One number on a cube, or a 6-sided die is rolled. You roll an even number. You roll a multiple of 3. So are those two events mutually exclusive? We have even numbers. So evens are 2, 4, and 6. And then multiples of 3 would be 3 and 6. Well, here I'm noticing, hey, there's an overlap. So since there's an overlap, these are not mutually exclusive. NME, not mutually exclusive. Two number cubes, so two dice are rolled. The sum is a prime number. The sum is less than 4. All right, so if I think of prime numbers, I would have 2, 3, 5, 7, 11. And I can't really go higher than 12 because, well, I'm rolling two 6-sided die and adding them together. And I misspelled the word prime. And then if I think of numbers that are less than 4, I've got 2 and 3. Well, clearly there's some overlap here. These are not mutually exclusive events. Two number cubes are rolled. The numbers are equal. So that means they're both 1s or they're both 2s or both 3s. And the sum is odd. Well, if I roll 2 1s, I'd have a sum of 2. If I roll 2 2s, I'd have a sum of 4. If I had 2 3s, I'd have a sum of 6. If I had 2 4s, I'd have a sum of 8. 2 5s, sum of 10. 2 6s, sum of 12. There are no odd numbers in here. So these two things are mutually exclusive. There was no overlap there. Each list is exclusive from the other. Next, we're going to refer to the spinner. So here we have a spinner with yellow, orange, red, green, blue, and we'll call that like lime green. And we have numbers 1, 2, 5, 2 7s, and a 6. Okay. You land on an even number. So we've got a 2, a 6. That appears to be it. You land on blue. Well, those are the only blue. There's no overlap. There's no blue even numbers. These would be mutually exclusive. Next one, you land on a number greater than 5. So 7, 5. Oh, actually 5 is not greater than 5. Now we have 7, 7, and 6. So these three values are greater than 5. Land on a yellow. Well, hey, this 7 was also a yellow. So these are not mutually exclusive since we shared a potential outcome there. Okay. Now let's get into some formulas. Like we mentioned before, anytime you have the word or, that's always going to indicate that we are adding probabilities together. Weird stuff happens, though, whenever we have events that are not mutually exclusive, because then we have to subtract the overlapped outcomes, all right? And that'll make a little more sense when we see some examples here. But when we see the word or, we're going to equate that to adding, but then we have to subtract the overlapping outcomes. All right. Up here I've got the deck of cards that we'll kind of reference. Again, this is available online. Do a quick Google search. You'll find thousands of these things, or take a picture of the screen right here if you need that for reference. Okay. A, what is the probability of selecting a king or a queen? So probability of king or queen. Well, first I need to figure out, are these mutually exclusive or not? And yeah, there's no overlap. There's no king-queen cards, right? It's either this or that. There's no both. So I'm going to take the probability of selecting a king and add that to the probability of selecting a queen. Well, if I look at my deck of cards, I've got 4 kings and I've got 4 queens. So the probability would be 4 out of 52 plus another 4 out of 52. That's 8 out of 52. And that reduces down to 2 over 13. What is the probability of selecting a diamond or a face card? So diamond or a face card. All right, well, let's go to our deck of cards. Looks like diamonds, I'm going to have 13 of them. So I'll have 13 diamonds. And then face cards, I've got 12 of those. But it looks like I've double counted these face cards that happen to be diamonds. So these guys here, they got double counted. So that's what we're going to have to subtract out. All right, so we're going to have the probability of selecting a diamond. Well, there's 13 diamond cards, so 13 out of 52. Then we're going to add probability of selecting a face card. Well, there's 12 of those, so 12 out of 52. And we need to subtract away those 3 that were both diamonds and face cards, because those got counted in each one of these. So we don't want to double count them, which is why we're subtracting that away. So we'll add 13 plus 12 minus 3. We get 22 over 52. Simplify that fraction, 11/26. All right, next up. It is equally likely that the pointer will land on any one of the 6 regions. So we have numbers 1 through 6, and it is color-coded. All right, so probability that our pointer will stop on an even number or a number greater than 3. So if I look at even numbers, I've got 2, 4, and 6. There are 3 of the 6 are even numbers. Then I'm going to add numbers greater than 3, 4, 5, and 6. So there's another 3 there. But now I have to subtract away any value that got double counted. So the even numbers, that was 2, 4, and 6. The numbers greater than 3 were 4, 5, and 6. Well, the 4 and the 6 were included in both of those. So I've double counted 2 separate occurrences. I need to subtract those away. If I combine like terms here, I'd get 4 over 6, and that's going to reduce to 2/3. Next one. Odd number or a number less than 5. So probability of an odd number or less than 5. Well, if I look at my spinner, odd numbers, I've got 1, 2, 3. So there's a 3 out of 6 probability there. Numbers less than 5, that would be 4, 3, 2, and 1. These 4 numbers here. So 4 out of 6. But now I need to figure out where was the overlap. I need to subtract that away. So we had odd numbers, 1, 3, and 5. And then numbers less than 5, that was 4, 3, 2, and 1. I've double counted the 3 and 1. Those were included in both of those. So I need to subtract out those 2 values. Combine our like terms, 3 plus 4 minus 2, all in the numerator. We get 5/6. All right, we're nearing the home stretch. A bag contains 5 red yellows. Wow. That would just be orange. 5 red marbles, 1 blue marble, 3 yellow marbles, and 2 green marbles. They don't tell me what the total is, but I'm going to go ahead and add those numbers together real quick to discover that the total is going to be 11. Okay. 1 marble is drawn from the bag. What is the probability that that marble is either red or it's yellow? So I want the probability that it's red or yellow. Well, there's no overlap. There are no red/yellow hybrid marbles. So I don't need to worry about subtracting anything. This one's just going to be straight up. I've got 5 out of the 11 are reds, and then I'm going to add the probability of selecting yellow, which was 3 out of those 11. So I have an 8 out of 11 chance that the marble I select falls into one of these two categories, either red or yellow. All right, last and final example here, folks. You are dealt 1 card from a 52-card deck. So, just for convenience sake, let me move that over. What is the probability that you are dealt a 2 or a 3? Let's see. There are 4 2s, there are 4 3s, and there's no overlap between them. I don't need to worry about subtracting away any overlap. So probability of selecting a 2 plus the probability of selecting a 3. We've got 4 out of 52 plus another 4 out of 52. That's going to be 8 out of 52, and that's 2/13. You're dealt a 7 or a red card. Let's see, I've got 4 7s. I've got 26 red cards, and it looks like these two guys are the overlap. So they got double counted. I've got 4 7s, 26 red cards, but then I need to subtract away 2. So 4 plus 26 minus 2. We're going to have 4 out of 52 plus 26 out of 52 minus 2 out of 52. And again, this represents the probability of getting a 7, a red, and subtracting away both the red 7. All right, let's combine our like terms. 4 plus 26 minus 2, we're going to get 28. So 28 over 52, and that's going to reduce down by a factor of 4 7/13. All right, last one, part C. You are dealt a red 7 or a black 8. Let's look at my deck of cards. A red 7, so one of these two guys. A black 8, so this guy here, this guy here. There was no overlap between those two. The red 7s and the black 8, those are two completely different occurrences. I can't have a card that is both red and black, and I can't have a card that's both a 7 and an 8. So this one, we're just straight up adding the two occurrences. We'd have 2 over 52, that's for the red 7s, plus another 2, those were the black 8s, over 52 there. That's 4 over 52, which gives us 1/13. All right, folks, that is it. That is all. You know the drill. If you have any questions, please do not hesitate to ask. And as always, good luck, have fun, be safe, roll tide.